Yo, what's up guys? So today we'll be talking about polynomial behavior when it's graphed. So first let's talk about zeros. So in a previous video I've talked about what zeros are, but just for a reminder, they're basically where the line or a graph intersects with the x-axis. Okay, so I'll just give an example of a line, maybe something like that, a little parabola right there. And the zeros would be one right here and 2 right here. Okay. So now what we're going to do is we're going to learn how to find the zeros of any graph. And how you find the zero is you basically just set y equal to 0 and you solve for x. So let's do an example. Let's do y is equal to, let's make our equal sign, negative 2x squared plus 8. Okay, so we set y equal to 0, right, first step, and from there we just do simple algebra. So subtract 8 from both sides, we have negative 8 is equal to negative 2x squared. Divide both sides by negative 2. We're left with 4 is equal to x squared, right? And if we find the square root, that gives us plus or minus x. Sorry, plus or minus 2 is equal to x. That's my bad. So we know that this line, or this graph, just by looking at the equation and with our new roots that we found, we know that it starts at somewhere around 8, okay, around here, and it starts at around 8, it's negative, and it goes to positive and negative 2. So our graph might look something like this, okay? But how do we work with more complex graphs? Well, sometimes finding the zero of a polynomial might not be as simple as just setting y equal to 0 and doing simple algebra. Sometimes you may need a factor. So let's give an example. How about another quadratic? Y is equal to x squared plus 7x plus 10. Okay? So first step, set y to 0, and then we have x squared plus 7x plus 10. So simple algebra is going to take a while for us to get an answer, and it's very inefficient. So let's factor, right? And in my previous video I showed you guys how to factor quadratics. So let's look at this. So what are some factors of 10 that add up to 7? Well, right away, if you've practiced enough, you can see that, okay, well, 10, 2 times 5 is equal to 10, and 2 plus 5 is equal to 7. So we know that the factors of x squared plus 7x plus 10 is x plus 2 and x plus 5, okay? So now what? What do we do from here? Well, this is an interesting case because, see, the x plus 2 is being multiplied by x plus 5. So what that means is that if one of these factors is equal to 0, then this whole thing is equal to 0. So then let's just find the values of x so that one of the factors are equal to 0, right? Each factor is equal to 0. So what do we have to add to 2 to make it 0? We just have to add negative 2, right? Negative 2. And what do you need to add to 5 to make it 0? Negative 5. So we're seeing a pattern here. It's basically just to find the zero of a function in polynomial in factored form is just finding the additive inverse of the other number. Okay, that's kind of it. So for 2, if you have positive 2, the 0 is going to be negative 2, and if you have positive 5, the 0 is going to be negative 5. Okay, simple. Let's get a little more complex. Polynomials can have more than 2 factors, right? So let's work on some that already factored polynomials and solve for it 0. So sometimes you might be given an equation that looks like this. How about x is equal to x plus 3 times x minus 2 times x minus 4 times x plus, that's x plus 1, okay? So this might look scary at first, but it's very simple, because if we're just taking the same logic that I talked about the quadratics, we just find the additive inverse of each number. Let's look at this first one right here, x plus 3. What value of x would make x plus 3 0? Negative 3, right? So now let's work faster. Negative 2. Well, additive inverse is 2. Negative 4, 4, and positive 1, negative 1. So we just found the 4 zeros of our function. So, as you can see here, for every factor, there's one x-intercept, right? 1, 0. But that's not always going to be the case. So let's check out some more complex aspects of graphs. By finding the zeros of a graph and some other simple properties of the equation, you can make some pretty good guesses on how the graph might look. But you cannot be sure, right? Multiplicity and positive and negative intervals can help you. So, multiplicity, let me write that down. How about we have the equation x plus 3 times x minus 2 times x minus 2. Okay, that's bad too, whatever. So, let's just find the zeros of this function, okay, or this polynomial. So, x plus 3, negative 3, right? X, negative 2, 2, negative 2, 2. So look, we just found the zeros. But notice, two of the zeros are the same value. So what does that mean? Do we just completely ignore one of them? Well, what actually happens is now the 2 value has a multiplicity of 2, because there's two factors that have a 0 of 2, right? Let's compare this to something that might be, I don't know, x plus 3 times x minus 2 times x plus 1, okay? And let's get a graph here, just a little graph right here. Okay, well, let's start with the second one, okay? Well, we know that there's going to be an x-intercept at let me go back. We know that there's going to be one at negative 3, right? Negative 1, and that's too close, 2, okay? I'm just estimating here, okay? So, it could look something like this, okay? Maybe something like that, okay? And this next one might look something like that, okay? So there's a few things you may notice. So it doesn't switch signs. It doesn't go from positive to negative like it normally does, right? It went from positive to positive. So this is because multiplicity also dictates whether there will be a sign switch. So with normal multiplicity, which is just 1, this is here. Normal multiplicity, which is just 1, it's going to be a sign switch. So it's going to go from positive or negative to negative. So positive, negative to positive. Okay, so positive to negative or negative to positive. With 2, it goes from positive to positive or negative to negative, so there's no sign switch. You could probably find a better proof or explanation online, but how I like to think about it is because there's 2 factors, there's kind of 2 zeros focused upon this point, that interval is kind of instantaneous. So there's an infinitely small point that's supposed to be negative, but it immediately switches back to positive. So odd multiplicities have a sign switch, and even multiplicities don't. Okay? So that's a very important thing to know about graphs and their behavior. Hey guys, thanks for watching. So sorry I had to cut the video a little short today. Next video we'll be talking about positive and negative intervals and end behavior. So thanks for watching. Check out Khan Academy, and peace.